Welcome to our first video of grade 10 functions revision. Please enjoy. If you do have any questions, please don't hesitate to leave a comment below. Thank you.
Let's start with this question 3. Previous question page. What 2021 KZN. So if we can check what we are given there, so when we start, you don't need to rush. Let's read the graph of f of x. We're given the graph of f of x and the graph of g of x. So a and b are x-intercept. Where is a? A and b are x-intercept. A and b are x-intercept. That's what we told them. Are x-intercept of the graph of f, and d is the turning point of f. Where is d? There it is. Turning point of f. D is the turning point of f. That's good news. The graph of g meets f. The graph of g meets f at b and e. At b and e. Where is e? Let's see. That's in the graph of g. Where is the graph of g? There you are. It's a straight line. Meets f at b and e. I don't think that is correct. I think it's going to be what? At a. It meets at a. Can you say that it's they're meeting at a?
Yeah.
So I think there's a typing error here. The graph of g meets f at what? At a. At a and e. So I would suppose this was going to be our point E. Suppose this is going to be our point E. Okay. C is the y-intercept of G. Okay, there it's C. So our first 3 marks, that is for question 3.1.1. 3.1.1, what we see there, they're asking for the coordinates of point A, the coordinates of point A and point B. 3.1, it's freezing today. 3.1, they are asking the determine 3.1.1 the coordinates of A, B, C, and D. So what we see here is that point A and point B are the x-intercept of F. Okay. So we'll write there point A and B are x-intercept of what? Of f of x. Can we see that?
Yes.
Then at A and B, f of x or y is 0. F of x, which is y, is equals to 0 at point A and B. Okay.
Okay.
So this means that if we want to find the values of what? Of x at A and B, we need to solve for x using the equation of f of x. Okay.
Okay.
So what we have there in f of x, we have our f of x equals to 1 over 2x squared minus 8. Then at A and B, as we've indicated here, at A and B, these values are equals to 0. That's what we see there, the values of y, the value of y is equals to 0 at A and B. So we will substitute 0 here. equals to 1 over 2x squared minus 8. Then because we don't have the coefficient of x, we will transpose the constant to the other side. It becomes much easier in that way. So it will have 8 is equals to 1 over 2x squared. Okay.
Okay.
Then what we do? We divide both sides by 1 over 2, or do a cross multiplication multiplying 2 by 8. Is that okay?
Okay.
It's going to be 16 is equals to x squared. 16 is equals to x squared. Therefore, the value of x, believe we have to square both sides, yeah?
Yes.
To remove the exponent 2, yes. So the plus or minus square root of 16 is equals to the square root of x squared. Why are we squaring both sides? To remove the exponent 2 there, which is in x, the exponent 2. Therefore, your value of x is going to be positive 4, or your value of x will be negative 4. Is that correct? Then if we look at point A, we will see that the value of x at point A is what? What is the value of x at point A?
4.
Thank you. So the value of x at point A is 4. Therefore, the coordinates of point A will be, is it 4 or negative 4, Tendo?
It's negative 4. Negative.
Yes. So the value of x at point A is negative 4. And what is the value of y at point A?
Positive 16.
At point A, let's check again. The value of x, the value of y at point A.
Oh, 0.
Yes, yes, yes. Please pay attention. This is your x-axis. The value of y at the x-axis is 0. So the value of y at point A is 0. Then what are the coordinates of point B?
The coordinates are is it 16 and 0?
Point B. Remember, we got two values. We got x is equals to 4 and x is equals to negative 4.
X equals to, it'll be B, and B will be 4 and 0.
So still for this 8 marks, for sure we've collected already 8 marks. What we see that is that C, can you see that C is the y-intercept as indicated here? C is the y-intercept of G. Then when we look at the equation of G, we see that the value of y at the y-intercept is what? In G. What is the value of y at the y-intercept of G? It's yes, negative,
Negative 4.
negative.
4.
Thank you. So the value of y at the y-intercept of G, it's negative 4. We see that in the equation here, the constant is negative 4. So this constant is the value of y at the y-intercept. So then this means that the coordinates of point C will be 0, since the value of x at point C, which is the y-intercept, is 0, and the value of y at C is going to be negative 4. Okay.
Okay.
So there we got the coordinates of point C. Can we wrap it up? And the coordinates of D? Let's look at D. Where is D? D is on f of x. Meaning D is on this equation. And then let's check again. What did they tell us? D is the turning point of F. So if they say D is the turning point of F, we know that the coordinates of the turning point are 0 and Q. These are the coordinates of the turning point of a what? Of a parabola. Okay.
Okay.
So this will mean that what is the value of Q, because at D X is 0 since they set a turning point, then what we need to look for is the value of Q at D, which is this one, negative 8. 3.1.2, what they're asking there is the length of CD. So when we are doing functions, when they ask you a length, you don't just jump and use the distance formula. There are some shortcuts that we can use, especially if the length is a vertical distance. Can you see this is the vertical distance?
Mm-hmm.
So if it's a vertical distance, it means therefore the length of CD is given as CD is equals to the value of Y at top minus the value of Y at bottom. This is the equation to calculate the length of to calculate the vertical length. So what is the value of Y at top? That would be the value of Y at C. Y at C minus the value of Y at what? At D. So what is the value of Y at C? That is negative 4 minus the value of Y at D, which is negative 8. You see how I substituted?
Yeah.
So it's a vertical length. So you need to check what kind of length that they're asking you. Usually in functions, they ask for vertical length and horizontal length. Okay.
Okay.
So this is going to be negative 4 plus what? Plus 8.
Wait, why are we plussing it?
Negative times negative is positive.
Okay, can't I just go and do my calculations and then get my answer?
It's very much correct. As long as you did this substitution, there's nothing wrong.
Yeah.
If the substitution is there, then we are very much here to get the final answer, which is close to what?
Positive 4.
4. Please, the length is always positive. The moment you get a negative length, it only means that instead of starting with the value of Y at top, you started with the value of Y at the bottom. That's why you'll get a negative answer. Then your length must have the SI units. Here, since we don't have centimeters or meters, we will write this is 4 units. Okay.
Okay.
That is 3.1.2. As you can see, we already get 10 marks. Okay. Then one of the questions, which is very much straightforward here. If we look at this question 3.1.3, we call it a reflection along, this is a reflection along the x-axis. So what we see here is k of x, which is equals to negative f of x. Why are we saying this is the reflection along the x-axis? Is because when you reflect along this line, the x-axis, the value of y changes the sign. If you can look at point D, if you want to reflect the point D about this line, it means this line is going to be our mirror. We will see point D this side. At the moment, the value of y at D is what? It's negative 8. But if we want to see point D on this other side, point D will be on positive 8, meaning it was reflected about the line x-axis. So why are we saying this is a reflection about the line x-axis? This is k of x is the value of y, and f of x is the value of y. So what we see here is that from the value of y to the other value of y, we see that the sign is changed. It's positive this side it's negative, as you can see the negative there. So the moment the value of y changes the sign, that is a reflection about the line x-axis. Is that okay?
Okay.
Thank you. So k of x is equals to what? is equals to negative f of x. So what is the equation of f of x? You just do substitution here. You just do substitution of your k of x. So your k of x is this one. Okay.
So wait, how do we know that that's k of x?
Please pardon me there. I wanted to say your f of x is this one.
Okay, yes.
So we need to substitute. So they're saying k of x is equals to negative f of x. So it's negative, open bracket, what is the value of f of x? F of x is equals to 1 over 2 x squared minus 8. That is f of x. Do you see that?
Yes.
Then we have substituted. Therefore, k of x is equals to a negative times a negative 1 times 1 over 2 x squared. That's going to give us negative 1 over 2 x squared. Then negative times negative is equals to positive.
Total.
Positive what? 8. Okay.
Okay.
There is your equation k of x. Was this hard?
No.
Yeah, it's just very much straightforward, especially the mark allocation there, it's 2 marks. So you don't need to bother. So how many marks did you collect so far? 12 marks. Now we are moving to 3.2. 3.2. Let's see. The following functions are given. What we see here, we see that we have a hyperbola and the exponential. Can you see that?
Yeah.
So I believe these are the simplest equations, especially in grade 10. Okay.
Okay.
So especially if you remember the notes that I gave you, let's see what they're saying there. I want us to look at the question. So we need to sketch a graph of f and g. So we're going to sketch these two graphs on the same set of axes. So this is very important to us. On the same set of axes. So they must be on the same set of axes, clearly showing all intercept. When they talk about intercept, they're saying, oh yeah, they're saying intercept with the axis. So they are referring that please show the coordinates of the x-intercept and the y-intercept, and also show what? The asymptotes where possible. Okay.
Okay.
So as I indicated how we sketch, we're going to look at our equation. So we're going to start by sketching f of x. We're going to start by sketching f of x. So let's have our Cartesian plane. This is how we sketch a graph. This is I believe this is the easiest way of sketching the graph. There we are. Okay. Now here, what we have here, we have our y-axis and our x-axis. Then we have the origin. Then how do we sketch the hyperbola? We start by sketching the axis or the asymptotes, not the axis of symmetry, the asymptotes. We start by sketching the asymptotes. So that's exactly what we are going to do. We are going to start by sketching our asymptote. So what we see here in f of x, by this value, we know in grade 10 our vertical asymptote is the equation x is equals to 0. It's there in the notes, Anetendo. So we're going to start by sketching that one, x is equals to 0. It's here on top of your y axis.
Why? I mean, how do I draw it like this? Do I just put like dotted lines over the y-axis, or can I just not put anything on there because we know that it's 0?
Yes, you can just leave it. Don't put anything there. What I'm doing here, I'm just reminding and making sure that we are aware that our hyperbola in grade 10 cannot touch the y-axis.
Okay.
Yes, you can just leave it like, because even if you make a dotted line on top of the y-axis, it won't be visible.
Yeah.
Okay. Then the next thing, we sketch our what? Our horizontal asymptote, which is at what?
At the above the x-axis in this case, because it's a positive 2.
Yes, it's at positive 2. Y is equals to 2. So we're going to put 2 there and make a dotted line, which is the horizontal graph in a way. Horizontal graph. So this is our horizontal asymptote. And then the next thing that we're going to do, we're going to sketch our graph looking at the value of A. Looking at the value of A. A is what? A is positive. That our graph is going to be mostly in first quadrant and in third quadrant. Do you remember that?
Yes.
Okay. And then the value of A is 2, meaning that the graph must be at least be a little bit further away from the asymptotes. So I will put it more of here, not that much close. And then this is in first quadrant. This is my first curve. Then I'll do my second one. This side not that close.
If my little graph, the one on the quadrants, is like 2 further away from the asymptote, is it gonna be considered wrong, my graph?
It won't be wrong. What matters here is that your sketch must look very accurate.
Okay.
So I will encourage you that when you draw your graph using this method, please use a pencil, because you might make a mistake, especially when you have to calculate your x-intercept. Look here, according to this sketch, the value of x must be negative. The value of the x-intercept must be negative. But if when I calculate here the x-intercept, I find that the value of x is positive, then it means I need to move this graph this other side.
Okay.
Okay, so always have a pencil ready. Okay.
Okay.
Thank you. So we see that the graph has the x-intercept. We're going to calculate the x-intercept for our graph. So x-intercept for what? For f of x, isn't it? That is to say f of x is equals to 0. Then we go to our equation, which is this one, f of x. We put 0 there, 0 where there is f of x, equals to 2 over x plus 2, and solve for x. If you can still remember what I showed you, I think it was last week, if not Sunday. And okay, this you multiply each term by 0, going to give you 0 is equals to what? 2 plus 2x, or you can just transpose that to the other side and then do the cross multiplication. Okay.
Okay.
Then what we see here, we transpose 2 to the other side, negative 2 is equals to 2x. Therefore, x is equals to what? Divide both sides by 2, the coefficient
X
of
equals
x.
to negative 1.
X is equals to negative 1. Look at my drawing. You see, it's very much accurate. Do you see it?
Yeah.
So whenever you do a sketch, try to make sure that whenever you do your x-intercept, at least they are very accurate. Okay.
Okay.
Thank you. Then we have drawn our hyperbola. They said we must indicate the intercept with the axis. This is how you indicate the intercept with the axis. You indicate this is the point -1 and 0. By doing this, you have indicated the intercept with the axis. Remember, this is the only intercept with the axis. The other thing that you can do, or what you must do, is to indicate the equation of the asymptote. So this equation of this asymptote is what is the horizontal asymptote. X is equal to what? 2. Is that okay?
Okay.
Thank you. Now I'm going to take a green pen to draw our h of x. So we will have to indicate. Okay, let's indicate this is h of x. Let's indicate this is h of x. Now I'm taking a green pen. We're going to draw what? Our h of x. Okay.
Okay.
So our h of x is the exponential. Before we draw the exponential graph, we need to consider the horizontal asymptote, which is exactly at +2. There it is. So it's already drawn. There's no need to do it again. Okay.
Okay.
The next thing, we need to check what is the value of a. A is equals to what? B is equals to what? Because we need to know the shape. What is the value of a?
A equals to -4.
Check again. Check. This is h of x. Look, focus on the equation that we have here. H of x is equals to 2 exponent x plus 2.
Oh, yeah.
So we don't have 4 here. What is the value of a here?
2.
What is the value of b then?
2.
Is it possible?
Uh,
Remember, the equation of the exponential is y is equals to a multiplied by b exponent x plus q. So a is the number that is next to the number that is raised to exponent x. So what we see in h of x is that b is equals to 2 and q is equals to 2. Are you with me?
yeah.
Then what is the value of a? The value of a is not visible, but not being visible doesn't mean it's not there, because the value of a is multiplying with b. So if a is 0, it means b must not be visible. Is that okay?
Okay.
So for the fact that b is visible, it means a is equals to 1.
Okay.
For the fact that b is visible, it means a is equals to 1. Is that okay?
Yes.
So always let's rely to this equation. Let's try to understand the standard form. Whenever we put the exponential function, you need to ask yourself these things. So what we see here is that b is greater than 1 and a is positive. Can you say that?
Yes.
So we're going to ask ourselves, is the graph above or below the horizontal asymptote? On your notes.
It's above.
Thank you. The next thing, is the graph increasing or decreasing? Look at A and B.
Increasing.
Thank you. Thank you. Those are the things that you need to like take note of. Yes, if A is positive and B is greater than 1, the graph is increasing. Then if it's increasing, what is the shape of the graph? If it's increasing, what is the shape of the graph? If it's increasing, the shape of the graph is going to be like this. This is the shape of the graph. Check there in your notes. If the graph is increasing, it's going to be like this. If it was decreasing, it was going to be like this. Decreasing. Okay.
Okay.
So these are things that whenever you are writing your classwork, your activities, you are practicing, you're preparing for the exam, you need to always go back to the notes and check, because these are things that you need to know whether the graph is increasing or decreasing. So let's draw the graph. So we have agreed that the graph is going to be in this shape. Okay. There it is. Then we have this point. This point is equals to what? What is the coordinates of this point? The value of x here is 0. So it's 0 and what? You can remember from our notes. This is 0 and what? Y-intercept.
Oh, is it 0 and 2?
Okay. Remember, we said our y-intercept in grade 10 for exponential graph, y-intercept in grade 10 for exponential graph is as follows: 0 and a plus q. So the value of a is a plus q. So remember we said the value of a is what? It's 1. What is the value of q? 2.
2.
So what is the coordinates here? 0 and what?
3.
Thank you. So these are things that you need to remember. If you can't remember this, then we'll have to calculate the y-intercept. Is that okay?
Okay.
You'll have to calculate the y-intercept. So this is 0 and 3. 0 and 3. 0 and 3. So this is this point, the y-intercept. So let's check, did you do everything that they asked for? Let's do the checking. 3.2.2, whether we're going to get all the 8 marks. Let's check. They did ask for drawing them in the same set of axes. We have done that. Clearly showing the intercept with the axis. We have done that. This is what we have done, just indicating those coordinates. Asymptotes were applicable. There we've indicated the asymptote, the horizontal asymptote and the vertical. So we are very happy. Yeah, that's also, it means you got all the 8 marks here. And then only one calculation we did there. Okay, I really wish that you can practice this, like redo it, like master this thing and then get all these marks. This 22 marks is for free.
Yeah.
Okay, then let's go back. 3.22, what are they asking there? Can you see the question?
Yes, for the domain of F.
The meaning of f. Is f a parabola or oh, here it's f. Here it's f. So f is a what? It's a is it a what? It's a hyperbola, ne?
Yes.
And it's there in your notes. The answer here, it's in your notes. 3.2.2 domain. It's there in your notes. This one is very straightforward. It says what in your notes? Domain.
The domain says that X is an element of negative infinity to positive infinity.
Domain of a hyperbola. Hyperbola. Check your hyperbola. I have indicated in your note that the domain of a hyperbola in grade 10, the domain of a hyperbola in grade 10 is x is not equals to 0. Yes, in grade 10. This is 2 marks for free. Check there in your notes, the domain of a hyperbola. X is not equals to 0. Okay, question 5. Determining the equation. This is what we are dealing here. I want to determine the equation of G. I'll see 5.1, they're asking the equation of G. I could just see that by just looking that way. I don't have the value of A and the value of Q. So question 5, they're saying the equation of the function G of X, the equation of the function G of X, is it visible? Okay, the equation of the function G of X which is equals to a over x plus q is shown below. It passes through the point, so this equation passes through this point, passes through the point, and the graph has a range of, look at this range. Are you with me?
Yes.
So what we see here on this range is that the value of y cannot be 1. Do you see that? The value of y cannot be 1. Why it cannot be 1? It means it has a what? A horizontal asymptote at y is equals to 1. The horizontal asymptote is at y is equals to 1. What is the horizontal asymptote? The horizontal asymptote is the value of q. So from this statement, we can see that the value of q is 1. Okay.
Okay.
So they're saying determine the equation 5.1. The question is determine the equation of G 5.1.1. The equation of G. So we will write down the equation G of x, a over x plus what? What is the value of q? We already know from this statement that the value of q is what? It's 1. Is that okay?
Yes.
Thank you. Then now we need to solve for a. We got the value of q, then now we need the value of a. How do we get the value of a? We are going to substitute this coordinate in g of x. So we're going to substitute substitute 4 and negative to this point at g of x and solve for a. So if we look at this point, what we see here is that the first value, which is 4 on the coordinate or on the ordered pair, is x. So the value of x in this equation is 4. If we substitute this point, x is going to be 4, and g of x, which is y, is going to be 2. Is that okay?
Okay.
So let's substitute. 2 is equals to a over 4 plus 1. Okay.
Okay.
Okay. Then let's start solving for a. We can do our magic again, multiplying everything by 4. You remember that? Or transposing. If you multiply everything by 4, 4 times 2, that is 8. Equals to a plus 4 times 1, that is 4. Therefore, what is the value of a?
A equals to 9. Oh no, sorry.
A equals to what?
Equals to 12.
A equals to what?
Wait, let me try it again.
It's 8 minus 4. Transpose 4 to the other side.
A equals to 4.
Is 8 minus 4. Take, yes, a is equals to 4. So we got the value of a, and then you got the value of q. Then you write down your equation of g. So what you're going to see here, it's 1 mark for the value of a, 1 mark for the value of q. Therefore, g of x is equals to 4 over what? Over x plus 1. You write down the equation. Okay. Now we move to 5.1.2. 5.1.2. Please pay attention. If you were to like check those notes that I gave you, you'll see that there is nothing in these questions. So look at 5.1.2. They're saying determine, look, determine the equation of h. So we're looking for the equation of h, which is the what? The axis of symmetry of h with a positive gradient. It's there in your notes, Anne? It's there in your notes. What is the equation? With a positive gradient. Give me that equation, 2 marks for free. In your note, it's written y is equals to what? With a positive gradient.
Y equals to ax plus 2.
Equation of the axis of symmetry. Axis of symmetry of a hyperbola. We are dealing with a hyperbola here.
Oh, sorry.
Y is equals to what?
Y equals to x plus q.
Thank you. What is the value of q in this diagram or in g of x?
1.
Thank you. So this will mean that the equation of h which they are looking for, we'll write it down. H of x is equals to what? X plus 1, because q is 1. Is it hard?
No.
It's hard for someone who didn't go through the notes. For someone who's not studying, this is very hard. Like they won't even know where to start. That's why I told you the note that I gave you, they are very direct. They are very direct. Okay, now we have our X of symmetry, 2 marks for free. As you can see, now we're taking 5 marks in the back. Now they're asking to sketch. But the way I understand it at the moment is that if they say sketch any graph, we will be able to sketch without struggling. 5.2, sketch the graph of h on the provided diagram sheet. Okay, we don't have that provided diagram sheet. We don't have this. Clearly show all the asymptotes and intercept with the axis. Sketch the graph of what? Of h on the provided diagram sheet. So if we were to draw this graph of h here on this diagram, are you with me? Hello?
Yes, I am.
So if we were to draw this graph of h here, if this was going to be our diagram, we will start by indicating the horizontal asymptote, which is not indicated here. We already know it's at +1 by our graph. So we will do something like this. And then now we're going to draw our straight line. What we know that our straight line will pass through this point. Is that true?
Yeah.
It will pass through this point, and it has a positive gradient, meaning it's going to be like this.
Okay.
Okay. Then if we were to solve for x here on this equation, the value of x is going to be -1 because h of x must be 0. So x intercept on this, on h of x is 0. Then x plus 1 is equals to 0. Then x is equals to -1. Is that okay?
Okay.
Meaning the other point is going to be this one. Then we take, let's take a ruler and sketch our graph passing through this very point. Okay, there you are, you see, it's passing. And then we go back to the question, what did you ask for? They asked for clearly show the asymptote. So the asymptote is there. This is y is equals to 1.
Okay.
And intercept with the axis. Intercept with the axis. You see this? So they're looking for this coordinate, which is going to be what? 0 and 1. As you can see, it's positive 1 here. 0 and 1. And then this one, it's going to be what? Negative 1 and 0. So by doing this, we have showed the intercept with the axis. How many marks? 4 marks. And then 5.3, write down the equation of the asymptotes. What are they looking for? Look, they're looking for what? Asymptote. The asymptotes of what? Of f. If, remember, you remember what we did on the previous question?
Yes.
We did substitute what f of x, you remember, ne?
Yeah.
So here they're saying f of x is equals to what? Negative g of x plus 3. So what is g of x? G of x is 4 over x plus 1. Do you see that?
Mm-hmm.
So we'll start by working for trying to see the equation of f of x. So f of x is equals to negative g of x plus 3. So what is g of x? So I have a negative outside. G of x is 4 over x plus 1 close plus 3 outside. Do you see what I did there?
Yeah.
It's very straightforward. Don't panic. Then let's see. Negative times negative times 4 over x. I'm going to get negative 4 over x. Negative times positive, it's negative 1. Then I have a plus 3 outside the bracket. Do you see that?
Mm-hmm.
Then I'm going to add like terms. When I add like terms, f of x is equals to negative 4 over x. Negative 1 plus 3 is equals to what?
Negative. I mean a positive 2, sorry.
Positive 2. So there is my equation of what? Of f of x. What did they ask for? Asymptotes. They asked for what? For asymptotes. So our first asymptote is the vertical asymptote in grade 10. Our vertical asymptote is what? Is x is equals to 0. Don't forget that. Then our horizontal asymptote is what? It's y is equals to q. So the value of q here is what? It's 2. Can you see that?
Yes.
So our horizontal asymptote in grade 10, it's y is equals to q. So our q here is 2. There we have answered the question. But this question is saying determine the values of x for which the two equations are equal. The two equations are what? Are equal. Do you have our notes?
Mm-hmm.
Remember we said h of x is the axis of symmetry. Okay. H of x is the axis of symmetry. So they are saying the two graphs are equal. Where are the two graphs equal? At the point of intersection. At the point of intersection. Are you with me?
Yes.
What are we looking for? We are looking for the value of x. So in grade 10, we know that the axis of symmetry and the hyperbola, they are equal at the following points, especially for this one with y is which y is equals to x plus q. If m is positive, they are equal at the following point: square root of a in your notes there, and square root of a plus q. That will be this point. And in your notes there, negative square root of a and square root negative square root of a plus q. That will be okay.
Okay.
Hello, if you can remember there in our notes. Do you remember?
Yeah.
Okay. So why are we doing this? They said to us f of x is g of x is equal to h of x, and we know that h of x is the axis of symmetry. That's what we got in 5.1.1. The next thing we check, what is that they are looking for? They are looking for the value of x. So meaning the values of x for which g of x is equal to h of x will be these ones. Okay. Therefore, x is equals to square root of what? What is the value of a? A is 4. What is the value of a? Where are you? Here is a g of x. This is the value of a. A is 4. You remember that? So a is 4. So square root of 4, the answer is 2. That is the value of x for the first one. The other one, or x is for that one, or x is equals to what for this one? Negative square root of a. What is a? A is 4, which is equals to negative 2. So we got the values of x, which is exactly what they are looking for. So 1 mark, 1 mark. We are in grade 10. We don't struggle. We don't struggle in grade 10. These are basics. It's just introduction of graphs. Then the last question. Okay, let's analyze. What they are saying in this last question of ours, they are saying G is below. G is less than h of x. That is to say, the graph of G is below the graph of h. In which side of x? On the negative side of x. This is negative. Less than 0, negative, if you can remember from our notes. So we will be looking at this side, the negative side. Is that okay? Okay, hello?
Yes.
We will be looking on the negative side, this side, because they are saying x is negative, x is less than 0. So when we read this statement, we are saying, where will G be below h of x? Okay, we're going to look at G with a red. Here it's G on this side, the one that we are talking about. This is G. You see that?
Yes.
And then this is G. Then let's look at H with the what? With pink. Let's look at H. Here is your H. You see that?
Yes.
So okay, now let's check at what they are saying. Where they are looking for the values of x for which G is below h of x. So let's look at G. G must be below h of x. Are you with us?
Yes.
G must be below. To be below is to be under. Okay.
Okay.
So let's check. There is your h. Can you see your h?
Yes.
Look. From this point, do you see here? If you look from this point, but you see from this point, you go to that side, you will see that your G is under H. Can you see this side?
Yes.
Who is above? It's H. Can you see that H is above here? And then your G is what? Is below. There is your G, it's below. From this point, the point of intersection, going that side, your what? Your G is below H. But if we were to look from this point, going that side, what will we see? What do you see? You see that your H it's below, but your G is above. Can you see that?
Yeah.
Thank you. So this is how we see, we answer this question. So what are we looking for? We're looking for G to be below h of x. For G to be below h of x, we must be starting from -2, going that side.
Okay.
And then remember they said we must look at which side, at which coordinate, from, or at which side values of x, from 0 to that side. So what we see here, if I can just remove whatever that I've just indicated there, thank you. Let's try to remove only what is not needed. What is not needed. Okay. If we look here from this point, which is -2, going that side up to the origin, the graph of h is greater than g. So where is the point? The point is x, it's what? It's greater. There is an equal to there, greater than what? -2. Where is -2? There, it's where we start here. You see that?
Mm-hmm.
And then less than what? We don't arrive. Do we arrive? Do we arrive? Yes, we can arrive. No, we don't arrive. They said x is less than 0. So it will be less than 0. So we don't touch 0 there, because they gave us a restriction that x must not be equals to 0, but it must be less than 0. So it means we start from -2 going to the right, but we don't arrive at what? At x is equals to 0. That's what we see there.
Okay.
So we give our solution in this case as an inequality. Okay.
Okay.
1, 2, 2 marks. Okay.
Okay.
And it's 5.4.2.
Thank you for watching. Please watch out for our next video. Please don't forget to subscribe below. Thank you.